believe I am live. I just had a question. Just had a question from an engineer on selective coordination, and I thought for about a 5-minute window here before my next meeting, I would just go live and talk a little bit about that question. So his question basically was, he's selectively coordinating a system using the circuit breaker tables. Now, I've done a couple videos on circuit breaker tables and selective coordination, how to do those. And the one video that's gotten a lot of viewers on my YouTube channel, that is an older video. And I've really got to go back and probably update it because we've come out with some new trip units since. But his specific question, these are, I put a reference link down below, which gets you to this page. This is the Eaton's Consulting and Engineering Resource for Power Distribution, specifically focusing on selective coordination. And what's nice about this page and the link that I have provided is it gets you to the information that you need pretty doggone quickly. So there's the SCD tool, which we are updating. And we have the Busman Selective Coordination Brochure. His specific question was on this document, Selective Coordination Application Paper. He gave me an image, but I'm not sure where that image was from, if it was from this specific or an older version of it. This document that he provided is, it's the Circuit Breaker Selective Coordination Tables. Now, there's a couple reference materials. There's this document, which is the Circuit Breaker Selective Coordination Tables. The other link is regarding the panel board. So basically, the difference between these two documents is regarding just a different view, perspective. This is produced, this document's put together based on the other document from our panel board switchboard group, product line group. They're basically looking at these requirements or looking at the performance of the breakers and knowing what steel they can wrap around the circuit breakers. And you know, for example, not all circuit breakers fit in every single panel board. So this reference document helps you. And so from a tips and tricks perspective, with regard to selective coordination, hey, James Smith, top of the morning to you, brother. I got a really short window. I got about 8 minutes before I start my other meeting. So thought I'd just share some tips and tricks on selective coordination. One of the tips that I would say is make sure whatever breaker you understand, whatever circuit breaker or fuse that you pick, what can you put it in? Because not all circuit breakers, not all fuses fit in every panel board, switchboard, motor control center, whatever it is that you're looking at, that any one manufacturer makes. So be mindful when you select your overcurrent protective devices, you may select it based upon this document, but you'll have to look at other documents and our consultant application guide and whatnot to see what device you picked, what equipment it fits in, and then what location does it fit in? Does it fit as the main overcurrent protective device in a specific panel board or switchboard that you were looking at? Can it fit as a branch or a feeder breaker? Or can it fit as a subfeed? So be very mindful of what equipment you can put it in. Now, this engineer's question was specifically, I'm going to go to a, he had an L frame. I think it was an L frame breaker. I'd have to look back at his email right here. He had an LD 600 amp LD breaker, so upstream of a F frame 20 amp circuit breaker. Now, if you'll notice, this F family doesn't have a 20 amp circuit breaker in the row. It goes from 15 to 40 to 100. There are breakers in between 40 and 100. There are breakers in between 15 and 40 amps. What this is telling you is that if just think about it from a selective coordination perspective, what do? I take the largest downstream breaker or fuse and I selectively coordinate it with the smallest upstream. So if I have a 800 or a 600 amp L frame breaker upstream, whatever, if I'm feeding a main lug only panel board downstream, I would look at all of my branch breakers and feeder breakers that are downstream, pick the largest one, and make sure that those two work, because if the largest one works, then all of the smaller ones will work as well. So in this case, the F-frame 20 amp breaker is not listed, but because it is greater than 15, I wouldn't use the 15 amp row. I would use the 40 amp row. And I know that a 40 amp row on an LD 600 amp breaker will selectively coordinate up to 12,000 amps. So that tells me that my 20 amp breaker, which he was looking for, which is in between the 15 and the 40, if the 40 works at 12,000 amps, the 20 will work at 12,000 amps. Now, you'll say, well, the 15 says 12,000 amps too. The reason they probably broke out the 40 is there's probably a difference somewhere all the ways up through the chain in between those two. Or it could just be a frame break. So in any case, the 20 amp breaker it would fall under the 40, not the 15 row, but the 40 amp row. So I personally like the using the tables because it really helps you understand how these pairs work. Okay, and this will make sure that the instantaneous region will selectively coordinate for those high fault currents. What you still have to do is plot these breakers and look at your overload, long time delay, short time pickup regions of the trip curve, because we make an, this table, you get into this table when your fault currents are so high that you're into the instantaneous region of both circuit breakers. Okay, so that's this table. We've tested these pairs of circuit breakers and we know the performance of them with regard to high fault currents. So another tip is use this table only when your fault currents are high enough that they're into the instantaneous region of both overcurrent protective devices. One example that I always use that I think is I went to the wrong slide. Let me find the right slide. One example I always use to help people understand is the BAB circuit breaker downstream of an F-150. In this case here, what I'm showing is the F-150 and the BAB. The BAB does not cross into the TCC curves are separate all the way down to 0.01 seconds. But what's really critically important is to know where your fault current lies on these curves. If your fault current is high enough that both of these circuit breakers, instantaneous regions, see the fault current, then you need to go to the tables. And in this case, an F-150 upstream of a BAB 20, I would go to the table, I would pick the BAB 20 downstream, follow it over until I get to the F-150, and then I know that for any fault current, 1500 amps and greater, then both, or greater than 1500 amps, both of these devices, more than likely than not, are going to trip. So what this table's telling me is for a 20 amp breaker downstream of an F-150, greater than 1500 amps, they're both going to open. So if I go back to this slide, I have, if I have 1000 amps going through both of these circuit breakers, I know that the downstream breaker will open, the upstream breaker will not open because of those tables. If I go greater than 1500 amps, I'm in 2000 amps passing through both of these breakers, I'm going to open both of those breakers. I know that for a fact. So the key thing is to remember that when you're looking at selective coordination, if you have two curves that don't cross, if all the way down to 0.01 seconds, don't mistake that to think for a very high fault currents, they will selectively coordinate. The moment your fault current goes higher than the instantaneous pickup of both of those devices, you have to look at the tables. That's the only way you know whether or not two devices will will selectively coordinate at the specific current that you're looking at, whether it's a bolted fault current, an arcing fault current, a ground fault current, regardless of the fault current. If that fault current is high enough, greater than the instantaneous pickup of both devices, and regardless of whether or not you have two TCC curves that don't overlap, okay, if they don't overlap to 0.01 seconds, that means that the downstream device starts to curve over under 0.01 seconds, and at some point they are both going to cross, and just because you have two devices that look good on paper does not necessarily mean they will actually function that way in the real world. So you have to understand what the TCC curves are telling you. You have to understand the limitations of the time current characteristic curves, TCC curves, and you have to understand when to start using the tables. Okay, so on the tables, remember, if you go from 10 or 15 amps to 40 amps, a 20 amp breaker, you would use the 40 amp row. It's in there, it's just not listed. We didn't list every single one of those, but I do have a goal of mine to include every one of those. Robbie Vargas, our morning lesson with Thomas. Amen, brother. And I have I'm right going into I'm chairing an NFPA 7dB meeting right now, so I got to go. Thanks, everybody. Thanks for what you do for electrical safety. Thanks for what you do for the electrical industry. Take care until tomorrow. We'll talk to you later.